Okay, hi guys. So in this video lecture, we'll be seeing more examples of even reaction. So let's get started. Suppose we have something like this, and we pass it on ETOH and we heat it. What will happen? We'll get something like positive charge here. Now the positive charge can actually rearrange itself to have something like positive charge at here. And now what can happen is we can have this as a major product in which ETOH will be attacking on this alpha hydrogen, and we get something like this. Okay, what happens in this case is Br ETOH and we heat it. What happens in this case is we will get first carbocation formation here. Okay, is there any scope of rearrangement? No, because if it comes here, there will be less number of alpha hydrogen than the present case. Hence, ETOH will do its work of removing the acidic hydrogen, and the major product form would be this. Okay, let's talk about this case where we have this and this. Okay, so if we just draw the timeline, or we just compare the rate of SN1, SN2 and E1, E2 reactions. So if we go along this way, SN1 rate increases. Why? Because in SN1 carbocation is formed, and more the stability of carbocation, more will be the rate of SN1 reaction. Okay, so if we go again along this again if we go along this, then again if we comment on E1, again rate of E1 increases. Why? More the stability of intermediate carbocation, more is the E1 rate. Okay, if we go along this, and we need to compare the rate of SN2. So what would be the rate of SN2 reaction? So if you look at the rate of SN2, the rate of SN2 would be determined by which is less sterically hindered group in this case. Okay, because the coming nucleophile will be facing more problem, which is the compound which is having more steric crowding. Hence SN2 rate would be decreasing. Okay, and again if you go along the group, we would have something like this, and we need to compare the rate of E2. Okay, so the rate of E2, actually again we have a transition state, it's a one step reaction. Okay, and in that case also we need to compare the stability of alkene group formed in the intermediate. Hence stability of the alkene group increases because of the more number of alpha hydrogen in tertiary in case of tertiary halide, then secondary halide, then primary halide. Okay, now let us see this example wherein we have something like this. Just a second. Yeah, we have something like, okay, so we have something like this, and if we react it with HBr, then OH actually takes up this hydrogen atom and forms OH, and again the Br minus actually attacks again on the R plus, and we form RBr plus a release of H2O. Okay. So why is this reaction going in the forward direction? Because obviously this is a strong base and this is a weak acid, hence this reaction goes in the forward direction. But if you look at this reaction, Br minus, and it's getting reacted with ROH, it's taking R plus, and we are getting something like RO minus. I'm sorry, it's taking H plus. This is taking H plus. Now in this case, what will happen is we'll be getting something like RO minus and HBr. Why this reaction doesn't go into the forward direction is, if you look at this reaction, this is a strong acid. Okay, it would again flow the reaction in the backward direction. Okay, because of the formation of a strong acid, hence this reaction will not go in the forward direction. Okay, so this was just two important facts. Just to remember any of the acid base or nucleophilic additions or you are doing in any of the case, just remember to see on which side strong acid is formed and weak acid is formed. By that way you can get a better clear understanding of how does the reaction mechanism happens. So in acid base reactions, this is a must to see that in the left hand, if in the right hand side strong base or strong acid is formed, then the reaction would go into the backward direction. So with this we come to an end of this lecture. In the next lecture we'll be talking about Sadzeff alkene and Hoffman alkene. Till then, good luck and goodbye.